block of mass 0.2 kg suspended from the ceiling by light spring of a spring constant K1 equal to 100 Newton meter. So we will first make the diagram. So if you make the diagram, it will be looking like this. This is a ceiling and we have a spring here and an object is hanging from it, and the mass of the object is 0.2 kg. Suppose we write M1, that is equal to 0.2 kg. Then it says a second block of mass 0.3 kg suspended from the first block through another spring of a spring constant K2 equal to 200. So we have another spring here and another block of larger mass M2 equal to 0.3 kg is hanging from it. Okay, and K1 is given. K1 is 0.2 kg and K2 is, sorry, not 0.2 kg. K1 is 100 Newton per meter and K2 is 200 Newton per meter. These two things are given. Okay, now find the extension in the two springs that we need to find. So how do you find it? So let us write the forces, different forces. So what are the forces that will act? So on the lower object we will have M2G downward. On the lower object we will have a force M2G downward, and then we will have an upper direction force, that is tension, the force by the spring, that we will write, suppose F2 equal to K2 x2. This much we are writing. The magnitude part we are writing just magnitude, so it will be like this, K2 x2. So since this object is not moving, this system is in equilibrium, what we can write is, we can write K2 x2 equal to M2G. These forces will be balanced, so we can write K2 x2 equal to M2G. So x2, the extension, x2 is what? Extension in the spring. So we can write M2G by K2. So what is M2? M2 is 0.3 kg, that is given. So 0.3 into G is 10 and K2 is given 200. So we are going to get 3 by 200. So 3 by 200 means this is in meter. So if you write in centimeter, it will be 3 by 2 centimeter, that is 1.5 centimeters. So extension in the lower spring is 1.5 centimeter. Okay, now we write for the upper one. For upper one, if you write for M1, what are the different forces? So one force is its weight, downward force, that is M1G. Then from the upper spring, so upper spring will exert some force, that will be K1x1. So we can write K1x1 in upper direction. And the lower spring will also pull it, because the spring will pull it from both the direction, because the spring is stretched. This stretched spring will try to pull the M1 in downward direction. So there will be one spring force also acting, K2x2 from the lower spring. So from the lower spring, K2x2 will act, and M1G is the weight, and then K1x1. Now if we equate these things, because the system is in equilibrium, we can write K1x1 equal to K2x2 plus M1G. So how much is K2x2? K2x2 is what we are knowing, that K2x2 is equal to M2G, that we have written here. So we can write K2x2 equal to M2G, M1G, and that will be M2 is 0.3, G is 10, and 0.2, G is 10. So this is 3 plus 2, 5 Newton, and x1 will be 5 Newton by K1. So 5 Newton divided by K1 is 100. So 5 by 100 in meter. So in centimeter it will be 5 centimeter. So in this way we can find the extensions in the two springs.